My dear students, let me welcome you all to the final revision edition of physics. In this edition, you'll be encountered with miscellaneous questions. Questions like, what is the scientific idea? Give reason, choose, and hopefully you'll find them interesting and useful. So let's get started. What's meant by the resistance of a wire 1 meter in length having a cross-sectional area 1 meter squared at 20 Celsius is 1.7 times 10 to the power of negative 8. What does it mean? Yes, it means resistivity. It means that resistivity of the material of the wire is equal to 1.7 times 10 to the power of negative 8 ohm meter. What's meant by the electrical conductivity of copper at 20 Celsius is 5.6 times 10 to the power ohm negative 1 meter negative 1. Here all you have to do is to convert conductivity into resistivity. It is the reciprocal. So it means that resistivity equals 1 over 5.6 times 10 to the power of 7. So it is 1.785 times 10 power negative 8 ohm meter. Still you have to mention something. Resistivity equals 1.7 times 10 to the power of negative 8 ohm meter. So the resistance of a piece of copper 1 meter in length and 1 meter squared in cross-sectional area is 1.78 times 10 to the power of negative 8 ohm. What's meant by magnetic flux density of a uniform field at a point is 0.02 Tesla. Okay, it's all easy. You're familiar with this question. It means this field would produce a force of 0.02 Newton on a wire 1 meter in length carrying a current of 1 ampere placed perpendicular to the field at that point. What's meant by self-inductance of a coil is 0.3 Henry. Inductance of a coil is 0.3 Henry. It means 0.3 volt is induced in this coil when the current flowing through the coil changes at a rate of 1 ampere per second. So it means an EMF of 0.3 volt is induced in this coil when the current through it changes at a rate of 1 ampere per second. What's meant by mutual inductance of two coils is 3 Henry. 3 Henry, so 3 volt, an EMF of 3 volt is induced in the secondary coil when the current in the primary changes at a rate of 1 ampere per second. What's meant by effective value of an AC current is 10 amperes. Effective value of an AC current is 10 amperes. Okay, it means the direct current that produces the same thermal effect, okay, same heating effect per second as the mentioned alternating current is 10 amperes. And now we've got another type of questions. What is the function of each of the following? Okay, we want to know the function of the shunting resistance, shunt. So function of the shunting resistance of the ammeter. Okay, first of all, it extends, it increases the range of the device. Okay, it decreases the total resistance of the device, total resistance of the ammeter, thus decreasing the heat produced in the device. Also, most of the current entering the ammeter flows through the shunt and only a small suitable fraction of the current passes through the galvanometer, so the device is not ruined. What is the function of the multiplier in the DC voltmeter? It increases the range of the device, it extends the range of the device, okay? increases the total resistance of the device, thus decreasing the heat developed in the device during operation. And what about the function of the curved poles of the permanent magnet in the galvanometer? Yes, this is being curved. Poles being curved will cause uniformity of the scale. The scale will be uniform, and we'll explain it one by one. Okay, so the function of the curved poles of the permanent magnet in the galvanometer is, to produce radial magnetic flux lines. Thus, the torque acting on the coil is maximum and constant, whatever, the position of the coil. In other words, the magnetic flux lines are always parallel to the plane of the coil. Consequently, the angle of deflection of the galvanometer is proportional only to the current required to be measured. Theta is proportional to the current, and this makes the scale is uniform. Function of the hair springs, or we call it spiral springs, in the moving coil galvanometer. They produce the couple which balances the electromagnetic couple. They bring the coil and the pointer back to rest position, 0 position, when the device is disconnected after finishing or after measuring the current. They lead the current in and out of the coil. And what about the function of the pair of brushes in the AC dynamo? They allow the generated current generated in the coil to flow from the coil of the dynamo to the load. And what about the function of the hollow metallic split cylinder in the motor? It makes the coil of the motor, it makes it rotate in one direction, because it reverses the direction of the current each half cycle. It reverses the direction of the current twice a cycle. And what about the function of the hollow metallic split cylinder in the dynamo? In the motor, it was to make it, rotate in one direction, and in the dynamo to obtain unidirectional current in the external circuit. So the function is, it reverses the direction of the current in the coil of the dynamo each half cycle to make the current in the external circuit, to make it flow in one direction. That's to say, to make the current in the external circuit unidirectional current. And now, when does each of the following quantities equal 0? When does the torque acting on a coil carrying an electric current and placed in a uniform magnetic field equal 0? So we need the expression that determines the torque. Torque is determined, by torque equals Bian cosine. So the torque equals 0 in the vertical position, where the plane of the coil is perpendicular to the field lines. Torque equals, as I said, Bian cosine theta. So torque equals 0 when theta equals 90. This occurs in the vertical position. When does the magnetic flux at any point inside a current carrying solenoid equal 0? It's all easy. It happens when the coil, the solenoid, is made of a doubly wound wire. So it must be made of doubly wound wire. When does the EMF induced in a wire moving in a uniform field? EMF. So we've got a wire that moves in a field, but no EMF is induced, so it must be moved parallel to the field. When the wire is moved parallel to the field, EMF induced equals BLV sine theta. So instantaneous EMF will be equal to 0 when theta equals 0, when it is moved parallel to the field. Theta is the angle between field lines and direction of motion of the wire. When does the force of a magnetic field on a current carrying wire equal 0? Okay, when the wire is placed parallel to the field, the force will be equal to 0. Once again, the expression should be written here. The relation, mathematical relation, should be written. The force is equal to BIL sine theta. Okay, so the force equals 0 and theta equals 0 when the wire is placed parallel to the field. When does the average EMF induced in a coil that rotates in a magnetic field equal 0? Yes, when the coil completes one cycle. Also, when the coil completes half cycle from the horizontal position. When does the magnetic flux density at the midpoint between two current carrying parallel wires, yes, equal to 0. Okay, this happens when the two wires carry equal currents in the same direction. Equal currents in the same direction. Okay, when does the current in the primary coil of a transformer, in spite of its connection to an AC supply, equal 0? This happens when the secondary circuit is unloaded. When the secondary circuit is open, a backward EMF is induced in the primary, which is nearly equal, roughly equal to the EMF of the supply. Okay, when does the electric conductivity of a pure silicon crystal equal 0? At absolute 0. Okay, because at this particular temperature, it is believed that all bonds in the crystal are intact. What are the factors that affect each of the following? What are the factors that affect each of the following? Force of magnetic field on a current carrying wire placed in the field. The factors affecting the size of the force. Okay. So formula is required here. Force is determined from BIL sine theta. So first of all, magnetic flux density of the field. Okay. Intensity of the current flowing through the wire, length exposed to the field, and sine the angle between the wire and the field lines, of course. Okay, what are the factors that affect the EMF induced in the coil of an AC dynamo? Factors affecting the EMF induced in the coil of an AC dynamo. EMF induced is equal to NAB omega sine theta. Okay, so the factors are, first of all, number of turns on the coil, area of the coil, magnetic flux density, and the speed with which the coil is rotated. And finally, sine the angle of rotation of the coil starting from the vertical position. And now we've got, we've got another type of questions. Yes, what is the logic gate which has only one input? Okay, it's all easy. It is the NOT gate. Okay. What is the logic gate which inverts the input voltage so that a high input voltage gives a low output voltage and vice versa? Of course, it is NOT gate. What is the logic gate which has two inputs and the output is high only if either of its inputs is high. Yes, either, so it must be or. What is the logic gate which has a low output voltage? If only one of its inputs is low, it is the AND gate. And now we've got a figure and we've got a question. The opposite figure shows some possible transitions. Okay, some possible transitions. For the electron of a hydrogen atom, so the figure is concerned with the hydrogen atom. Which transition gives the photon that lies in the infrared region? Is it A, B, or C? Of course, it is line C. And which transition gives the photon with the highest energy? Highest energy means the greatest gap, so it must be line A. And what is the name of the series, okay, that line B belongs to? Series, it is Palmer series. Okay, and now we've got another type of questions. The opposite figure shows the energy level diagram for helium neon laser. Okay, use the diagram to answer the following questions. How is the helium atom driven into metastable energy level E3? How? We want the method. Yes, by using high frequency electric field, feeding the tube from the outside, or using, yes, high DC voltage inside the tube, causing electric discharge. Question number 2, concerning the same figure. How is excitation energy transferred from a helium atom to a neon atom? All right. Okay. When a metastable helium atom collides with a ground state neon atom, okay, when they collide, the excitation energy of the helium atom is transferred to the neon atom. And this way, E2 becomes more heavily populated than E1. Why do neon atoms accumulate in energy level E2? Okay, this is very important. We've got population inversion in this case. Population inversion is maintained because, first of all, the metastability of level E3 ensures a ready supply of the energy required to excite neon atoms to level E2. And what about atoms in level E1? They decay rapidly to the ground state, okay, to neon ground state level. Another type of question: what happens when a metastable helium atom collides with a ground state neon atom? Okay, it's all easy. Yes, the excitation energy of the helium atom is transferred to the neon atom. And this way, a population inversion situation can be reached, and this makes the stimulated emission predominant. Okay, what happens when high energy photon, such as gamma ray photon or X-ray photon, collides with a free electron? Yes, this is very important. The photon scatters. Scatters means it changes its direction. Scattered photon has longer wavelength, lower frequency, lower energy than that of the incident photon, because the incident photon loses part of its energy. The energy lost by the incident photon is gained by the electron. What happens when an electron having very high kinetic energy collides with a target made of material having high atomic number? Yes, this is very important. The two spectra of X-rays are produced. What happens when a white light is a continuous spectrum, is passed through sodium vapor? White light is passed through sodium vapor. Dark lines appear because the vapor absorbs its characteristics wavelengths. Dark line appears because the vapor absorbs its characteristic wavelengths. What happens when X-rays are passed through gases? Okay, gases are ionized. What happens when X-rays pass through a crystalline material? Okay, this is very important. X-rays diffract, so interference patterns are produced. These interference patterns reveal the structure of the crystalline material. And now we'll make some comparisons. Compare between AND gate and OR gate with respect to the way the transistor is used to serve as each one of them. Okay, for the transistor to serve as an AND gate, it should have 2 or more emitters. And to serve as an OR gate, 2 or more transistors are connected in parallel to each other. And now compare between DC emitter and DC motor with respect to the direction of the current in the coil in each one of them. DC emitter and DC motor. Well, direction of the current in the coil of the motor is reversed each half cycle, but the current flows in the same direction in the coil of the emitter. And now we want you to compare, yes, between the hot wire emitter and moving coil galvanometer with respect to the uniformity of the scale of each one of them. Great. Scale of the hot wire emitter is not uniform, but that of the galvanometer is uniform. And now we've got another type of question. We've got a figure shown in front of you right now. Okay, it is about laser. What is the value of the pressure inside the tube? As I said, it is about helium neon laser. What about the value of the pressure inside the tube? Yes, we should memorize this. It should be 0.6 millimeter Hg. What is the lasing medium in the helium neon gas laser? Lasing medium is neon atoms. And now, what happens if the 2 mirrors were removed? Once again, the device cannot produce laser because the 2 mirrors are responsible for amplification of laser light. They are responsible for building up the intensity of laser beam to enable laser light to emerge from the mirror having the lower coefficient of reflection and completing the stimulated emission. What happens if the tube did not, yes, contain helium atoms? Okay, this is very intelligent question. Neon atoms or the lasing medium could not be driven into their metastable state. They could not be driven into a situation of population inversion. Thus, the device would not be able to produce laser light. And now let's solve some problems. In front of you, we've got a figure. The current gain of the transistor shown in the opposite figure is 49. Calculate the value of V out. Okay? There are figures written on the diagram. Your attention, please. Current gain is equal to alpha E over 1 minus alpha E. So current gain, which is 49, equals alpha E over 1 minus alpha E. In this way, alpha E is obtained. It will be 0.98. Current of the collector, it's so easy to obtain it. Alpha E times current of the emitter. So 0.98 times, yes, 250 milliampere. It should be, yes, converted into ampere multiplied by 10 power negative 3. So IC equals 0.245 ampere. VC equals ICRC, right? So 0.245 times 10. In this way, we'll obtain VC. It is 2.45 volts. V out equals, yes, 6 minus 2.45, it will be 3.55 volt. Use the shown circuit to find the reading on each of the voltmeters. Use the shown circuit to find the reading on each voltmeter, knowing that the effective value of the supply is 100 volt. Your attention. On the circuit, there is V supply equals 100 volt. Resistance equals 50. Inductive reactance equals 25. Capacitive reactance equals 25. So we are in a state of resonance. Okay? In a state of resonance, the impedance Z is equal to R. R is given to be equal to 50. So Z is equal to R, and it is equal to 50. A resonance, V supply total voltage equals the voltage across the resistor. So voltage across the resistor will be 100. So it's all easy to find the current. I equals 100 over the resistance, which is 50. So the current equals 2 amperes. V1, yes, what about V1? It is the voltage across the resistance. And I said it is equal to the total voltage. It is 100, and it can be calculated 2 times 50, it is 100. V2 voltage across the inductive coil. VL is equal to IXL. So 2 times 25, it is 50. And in resonance, XL is equal to XC, VL equals VC. So V3, which is VC, it will be also 50 and can be calculated 2 times 25, it is 50. And the most important part here, voltage across both capacitor and inductor, it will be, yes, 0. It is calculated by getting the difference. So 50 minus 50, it will be 0. In this way, we've come to the end of the final revision edition. Before I go, I just want to say something. All you have to do is to trust yourself, expect the best, and go to get it. And may God give you resounding success and give you the desire of your heart. Bye-bye.